Funny. Hey, thanks everyone for coming along today. I know it's a busy time of year. So my name is Shirley Coyle and I'm the Programme Chair for DCU's new course in Global Challenges. Okay, so today I'm going to give an overview of our new course. I'll start off by giving an introduction about what it's all about, and then go into a bit more detail about the actual course structure and the types of modules, types of learning activities that the students will be doing. And then talk about why students might like to take this course and the possible careers that it could lead on to. And then if you have any questions, please just add them into the Q&A function. So why might students be interested in this course? So there's a lot of global challenges that are affecting our world today. So for example, climate change we know is happening, and there's evidence that this has been the hottest decade on record. And climate change affects all parts of the world. Then look at things like global health, and obviously everyone is impacted by the COVID pandemic, and that's affecting every single country in lots of different ways and affecting a lot of different aspects of our lives. Then another challenge is energy. So obviously, we have a limited amount of resources. We need to look at new ways of conserving energy and generating energy. If we look at the challenge of food and food supply, there's still about 10% of the world's population that are affected by hunger. And similarly, water, another basic human need. There's about 1 in 3 people that still don't have access to really safe water supplies. So this course looks at tackling these challenges like this at both a local and a global level. So how can we actually face these challenges? So if you have to think about them, they're all interconnected. So if you take one, for example, and consider food. So food is obviously affected by climate change. If there's an effect on the agriculture and crops that are being produced, that can lead to a lack of food. If there's conflict in a country, that can affect the food supply. And then if there's a lack of food or scarcity of food, there's obviously knock-on effects on the health of the population. Another global challenge, looking at energy use, that's obviously affected by climate change as well. And obviously there's huge effects on the environment, affecting all of us, our own health, but also effect on wildlife and the world we live in. And linked to that environment, obviously there's effects on water. So say by burning fossil fuels, we're affecting the air and the air pollution, and that's going into our waters and affecting life within the water as well. So one way to address these problems is using technology and science. So we can create new materials, look for different types of solutions to address these challenges. But just using tech and science on their own isn't enough. So you have to think about other impacts. So suppose you develop a new way to generate energy, but it might be more expensive. So you have to consider the economic impacts of any of these new developments. And the other thing, if you're designing new technology, you have to look at people's behavior, and are they actually going to accept this new technology? And are they actually aware of these global challenges? Like why should they use this new approach? Or why do we need to create these solutions? And linked to that and people's behavior is governance, and looking at how countries are managed, how systems are managed. And also related to that is looking at policy and what laws are there, and how can different policies impact things like climate change and change the way we do things. And all of this has to be done then considering the limited resources that we actually have on the earth. So the only way we can tackle these challenges is by having interdisciplinary working, so coming together, collaborating. And that's the only way you're going to get innovation, by having people working together across different disciplines. So that's why this new course brings together a unique combination of technology and social science. So to do that, we've brought together 2 schools in partnership. So we have the School of Law and Government, so looking from the social science side of things, and then the School of Electronic Engineering, looking at technology and science. So just to give a bit of background about the schools involved. So the School of Law and Government have 48 academic staff. It's a very top performing school in terms of research. The staff are very much involved in influencing policy, in talking to the media. You hear them on the radio, putting out podcasts. And they're very much involved in an innovative teaching style. So, for example, they run moot courts where they have like a simulated court. So the students would go through role play. So it's really interactive, engaging teaching methods. And then the School of Electronic Engineering is where I'm based, and we have 20 academic staff. And we obviously have labs for practical work, so we have technical staff to support those labs. And we're also involved in very innovative teaching approaches. So using project-based learning, real-world examples, a very applied learning approach. And again, our staff are also very much engaged in research, particularly research that involves industry engagement. And we have staff affiliated to a number of the research centres that work across disciplines. So the Advanced Processing Centre, which looks at new manufacturing methods and materials, and then the Insight Centre for Data Analytics as well, which works across computing and human performance and health as well. So the Electronic Engineering Building is based, if you look at the top picture, that's the engineering building, and we're in there. And there's a new building underway just beyond those DCU pillars called the Futuretech Building. And we're going to have a floor in there and have an idea space, which will be ideal for global challenges and for generating ideas and new innovative solutions to tackle these global challenges. So the course is taking a quite innovative approach, so moving away from the traditional big lecture halls. We're going to have 20 students in the first year, very much continuous assessment based, a lot of practical work and projects. So less formal exams at the end of semester and a lot more project work and continuous assessment throughout the year. And very much challenge-based learning. So students will be given challenges to try and actually figure out what the problem is themselves and work through those projects. And so with these projects, students really need to research themselves and find out what the user needs are and look at the broader views of all the stakeholders involved in a global challenge. And so that brings in a lot of social science aspects. And then they need to see, well, what could be technically possible, looking at new technologies, and also consider the ethical implications, and also think of law and government and what's just, what's fair, and what other constraints are there. So looking at the societal and economic implications of developing a new technology solution. So it really is very much at the intersection of social science and technology. So I'm going to just run through the course structure, looking at each year and the different types of modules that the students will be studying. So every year there's a big project that's interdisciplinary that is supervised by both schools. So that's a Global Challenge project. It's shown on the right side under the yellow heading. And then to support that project, we have a number of strands in the technology side or in the law and government in the social science side. So say in first year, we're looking at the fundamentals of maths and science and technology. So for example, we're looking at the mathematics of change. So everything in the world is changing, and we're looking at very applied ways of using maths to quantify that. Linked to that as well, we're looking at data analysis, so how to look at trends in data and using that to solve problems, to make decisions based on analysis of data. As I said, there's a lot of project work involved, and when students finish this course, they'd be involved in leading projects and running different projects. So we're looking at project planning and management of projects. What makes a good leader? How do you keep things on track? How do you propose a project? Then in terms of the other tech subjects for semester 2, we have looking at science for a sustainable future. So understanding the basics of science, the fundamental science, about the environment, about materials, understanding how things work. And then we also have looking at modern technology for a changing world. So in that module, we'll be looking at computer systems and how computers are connected throughout the internet and cloud computing, and how that can be used to solve global challenges. Then from the social science side, we have an introduction to social research methods, specifically for global challenges. And that looks at things like how do you ask good questions, asking the right questions, design surveys, conducting interviews to find out, to get that empathy and understand user needs. There's an introduction to politics, looking at politics in a changing world. And then there's a module there on an introduction to global challenges. So to understand the broad context of the challenges and how they're interrelated, some of the causes for them and the effects. If you change one thing, what's the knock-on effect on another global challenge? Then looking at global development throughout the world and looking at inequality and the reasons for that and how that links to politics and the different effects of it. And then I mentioned we have this Global Challenge Project, which brings together all of the learnings from those supporting modules. And the project is to investigate people's knowledge of global challenges. Because one of the big issues is creating user awareness. So people, won't change their behavior unless they realize, why they're doing it. Why should they have to change things? So as part of this, students are going to be carrying out a survey. So just for your information, the UN Sustainable Development Goals there's 17 goals that cover things from food and water to responsible development, smart cities, and the goal is to improve people's life and improve the environment for everybody, and to do that in a sustainable way and ensure peace across the planet, with the goal of achieving these by 2030. So it's a 15-year plan that's been put in place by all UN member states. So in the first stage, the students would be designing a survey to see what their fellow students know about the UN SDGs. So they need to design the survey, implement it, look at sampling, so how many students they need to ask in order to get a significant result. Think about bias, so if they ask the environmental studies students, are they going to know more about climate change than the others? And also look at the ethics and things like data protection and things involved in carrying out a survey. So once they've actually put the survey out, then they'll need to analyze the results, perform statistical analysis, visualize that, the results they get. And so that they do that in semester 1, and then as part of semester 2, they need to take those results and try and figure out how they're going to address the issue. So they're using creative problem solving skills to try and come up with an innovative solution that's based on technology. And the idea is that they develop something that will address that gap in knowledge. So it could be a website or it could be an app, just some way to address the gap that they have discovered themselves in their first semester. And so that idea of having a project and then having other supporting modules that are facilitated by and guided by the staff follows on throughout the 4 years of the program. So you have this project and then all these other modules serve to really scaffold that and support the different activities they need to do. So say data analysis will help them analyze the results of their survey. So just moving on then to the other years. So in year 2, again, following on with the maths theme. So it's very important that they have good data analytical skills. So they'll be looking at things like statistics. So looking at the world, looking at trends, looking at modeling the world. So looking at things like, the pandemic and looking at case numbers, or it could be looking at the effect of climate change on water and sea levels. So using statistics and models to look at real examples, and the course is very much applied like that. That we've designed all these modules to take real world data and to apply maths and science to try and understand and to solve some of those issues. Then another aspect of technology is looking at sensors. So we could use sensors to sense when the bins are full, and that can improve the efficiency in a smart city. And all those sensors then are linked to the Internet of Things. So things like wearable technologies could be linked into that. And it's to improve the efficiency of business, of people's health, energy use. There's a huge range of applications of that. Then in terms of design and project management, we have innovation and entrepreneurship. So trying to generate that entrepreneurial mindset and a way of innovative thinking, and that sort of approach where you can solve problems and use creative problem solving. And that's also linked then to the technology systems design, which is very much looking at a user-centered approach to designing systems, no matter what kind of system it is, taking a certain approach to looking at user needs and designing a system around that, taking into account all the environmental, economic, societal, sustainability impacts of that. Then on the long government side, we have a further module looking at qualitative research methods, so building on from the first year module. We've modules then looking at global governments and politics, looking at international law, contemporary issues. And then there's some options then looking at some modules that are linked very much to the UN Sustainable Development Goals, looking at conflict and peace and security, or else looking at climate change and how policy can influence that, looking at politics, and then the social science aspect of human behavior and how that relates globally to these challenges. And then again, there's a global challenge project, which is a large part of the continuous assessment. And in second year, that's a design challenge, and it will be a team project again. So in this case, the students will be given a challenge of being given a design brief of a particular scenario in a developing country. And so for this challenge, we're planning to use a competition that's run by Engineers Without Borders, where they have different development partners around the world, and they would describe a scenario where communities need a solution to a problem. So they would be given this challenge, given a brief, and from that then students would need to figure out, well, what's the real problem and how can we solve that? And as part of that, they would pitch their idea at the end of the year, work through it on it throughout the year. And then in May, they'll pitch their idea and have a poster presentation, and they'd have the opportunity then of actually going to a grand final against other institutions. Then moving on to year 3, so we have a slightly different approach this year because we've an interplacement, which is integrated training. So the second semester, the students will be out in their work placement. But in semester 1, then we're looking on from the technology side, we're looking at artificial intelligence and machine learning and how that can be used to transform society. Another area linked to that is looking at computer privacy, security systems, obviously very topical at the moment with cybersecurity. From the social science side, again, we've a module on problem solving, quantitative research methods. So building on from the previous years to really look at methods of social research and understanding human behavior. And then we have options again in gender and politics, or looking at politics in different regions like South Asia. And again, looking at different global issues, we have a module on analysing public policy and the challenges that brings. And then this year we have a global challenge project. It's slightly shorter because it's just in semester 1. And that again is a team project, and it's based on using AI to address global challenges. So again, that'll be quite an open project for students to choose and find an area of interest to them and see how technology can be used to tackle that problem, while also taking into account all the other societal, ethical, and other impacts that it would have. Sorry, I forgot my animations here. And then, as I said, the students would go on an interplacement. So this is a 9-month placement, so from January through to September. And here I've shown some of the companies that the engineering students would typically go on. So we have an intra-office in DCU, and they work with different companies. So the companies would give a job spec and they'd interview students. So students have the opportunity to apply then and go for interview. So these are some potential placements that we'd have, but we'll also expand this out to include government departments, NGOs, the Global Challenges Programme will have, I think, a broader scope of areas that the students could work in. So then in year 4, We've got some options, so specialising a little bit more. So on the technology side, renewable energy is obviously really important for whatever area the students go into. So we've a module on renewable energy, and then an option then to specialise this a choice in semester 2. So they could go on and look at decarbonisation for a sustainable future. So looking at different ways of generating energy, moving away from fossil fuels. We have a module then looking at healthcare to smart healthcare, using digital technologies to improve the efficiency of healthcare, whether that's using wearable technologies or could be looking at improving the healthcare system and remote monitoring, and yeah, there's a broad range of applications there. And then manufacturing systems is looking at advanced manufacturing, so like electronics are getting smaller and smaller, and looking at the limitations of that and the challenges that brings, and to give students a knowledge of those new emerging technologies. Then on social science, we're looking at, it's going to be in 4 years' time, so what new techniques are there in social science research. And then in law and politics, there's an option to look at different regions, so Chinese politics and foreign policy, or it could be post-Soviet politics, or the politics of Middle East and North Africa. And then in the, move on to my animations, we've got international relations, but looking at the effect of the computer age and how the way people communicate now has changed. And then again, there's a Capstone Project, and I'm going to give just a couple of examples of what this Capstone Project would look like, and the types of things that students will be able to do, not only by year 4, but the type of work they might do when they go out into the workplace. So the first scenario, and this is kind of the concept of when we came up with the course, what should students be able to do? So suppose we gave them this challenge that, there's an isolated village, it's in a developing country that's got a really hot climate, but the people have really poor living conditions. They've got a very poor water supply, it's not reliable, and no electricity supply. So what can you do to improve their quality of life? So using social science skills and the investigative skills that students would have, they might go in and look and see, well, what resources are available, and then what do people actually need? And you might figure out, okay, well, they're burning a lot of fossil fuels, that's causing health effects. They're, the air pollution indoors. So they need a sustainable power supply so they can have a cleaner way of generating power. So you need to think about, well, what's technically possible and how could we actually implement it? But then not only that, not just about the technology, but who's going to manage it then? And are there any environmental impacts for that particular country? What policies are there? And are there any particular legal requirements in that country? And then really important, is it going to be sustainable? So the students might, once they've addressed all these questions, decided, okay, well, it's hot, there's lots of sun, we need solar panels, and that's, a renewable source of energy. So it's a great idea. But they need to have some kind of technical knowledge to see, is that feasible to do? They also need to consider the governance, so who's going to manage this once it's implemented? And then look to see, well, will the people in the village actually accept this, and will it be used? So they might devise that and develop their report and their ideas. And then at the end of the year, the students would pitch their solution to the academic staff, and we'd invite in an expert from, say, an NGO to give feedback on their assessment. So that's one possible project that students could do. Another one, probably closer to home, is looking at how could you improve mobility in the city. So you see the picture here of the cars lined up, a lot of air pollution. Sorry, excuse me. So traffic has a huge environmental impact. And not only that, having an effect on people's health, but the commuting time is also affecting people's quality of life. And also within a city, the deliveries getting delayed or affecting how efficient the business is delivering its services. So again, the first step is to investigate the problem and find the root cause of the problem. So they want to improve mobility in the city. They need to look at the user needs. So is it the commuter there that's driving in and out, or is it the bus driver they're looking at, delivery drivers, or is it, you know, the cyclist who's being exposed to all these exhaust fumes? So they need to see, well, what information is available, what technologies are possible, and look to other countries and other cities, see what's worked elsewhere, what can they learn from that. Think about the environment and the policies that are in place in the city. So they might come up with a solution to improve the efficiency of public transport. So you've got more people, you know, leaving their cars at home and being happy with this public transport system. So the way they could use that is within a smart city. So the smart city has lots of sensors. It knows the location of the buses and the amount of people going onto each bus using sensor technologies for, you know, identifying passenger numbers. They could also take information from weather data that's available to look, well, what's people's behavior? Are more people likely to want to take the bus if it's raining, or, you know, people go in their cars, and use that information then to make the transport providers make better decisions and provide a more efficient service. And use all of this, the huge amount of information, to design better infrastructure for the future. So once they've developed their solution, again, they'd have their final year presentation, and this time the academic staff might invite somebody in from a local authority to help give feedback and to assess the student's pitch. So that's just an overview of the 4 years, the modules, the kind of things they'd study. So some of the advantages of this program are the small class sizes. So we're quite excited about, you know, teaching in this way, having smaller numbers where there's much better engagement with the students, you know, working with the students on their assignments and helping them create assessments. So we're very much an innovative teaching approach. And that way of teaching is going to really prepare students to be ready for the future, where they can investigate things themselves. They're given challenges, and they'll get a certain amount of support from, you know, from their modules they're studying, but they'll be encouraged to go and find out things for themselves as well. So it's a new program. It's the only one of its kind in Ireland and one of very few around the world. And it's been designed on industry needs, seeing, well, what skills do graduates need for the future. A big advantage with this, and like other DC programs, is the industrial placement in year 3. So they'll get real world experience to go out on work placement. So possible careers. I think that, you know, students like this, they're not going to be engineers or lawyers, but they're going to be leaders. So this the kind of person who's going to be leading a team, being able to work across disciplines. So they'll be able to work with the lawyers, with the engineers, with the designers, with the finance people, because they understand the bigger picture, and to be able to bring all that together. So to understand the problems and the issues and the challenges, but also being able to create solutions to those problems. So it's really a course for people who are passionate about these global challenges and want to create change. So knowing enough about technology and knowing enough about the bigger picture to be able to implement change. So possible roles would include project leader, project director, any jobs to do with innovation, looking at strategy, looking at sustainability, definitely anything to do with smart cities and looking at innovation within cities, social responsibilities managers, politicians, researchers. There's really quite a broad range of skills and careers that students couldn't get involved with, and a range of sectors. So on the intra slide, I showed lots of different companies are involved. There's also, you know, government agencies and the UN, NGOs that we very much possible career paths as well. So the details of the course are it's DC 189 and it's 4 years. There's a maths requirement. It's a minimum of H5 or an O2 in maths. So it's the engineering degrees are H4, so it's slightly lower because there's not as much technical detail as the traditional engineering degrees. All the modules are very much bespoke and they're designed just for these global challenges. So that's the brief overview. I'm happy to take any questions if you want to type into the chat.